Hi class, let's take a look at problem C. Now I provided the sketch of problem C here so we can get an idea of what the graph is going to look like. But before we actually jump into the problem, I wanted us to review the actual cases as we're solving quadratic equations. So as we're solving quadratic equations, you could end up with a situation where there's no x-intercepts, and that would be a no solution. This one is going to give us that x is equal to a plus bi, or technically complex solutions. Or you could end up with a single solution or two solutions as part of the solution set. And notice that on this one, if you're looking at the graph, well, it doesn't seem that we're going to have x-intercept. So this is going to end up a no solution. So let me actually start by solving by using the quadratic formula. And the first step is we need to get it to 0. So the quadratic formula for us to apply it only works if you technically have the equation as ax squared plus bx plus c equaling 0. In this case, that is not satisfied here since it's equal to -10. To set it equal to 0, we'll just be adding the 10 to both sides of the equation, which is actually going to give us a 5x squared plus 6x plus 10 equal to 0. And then from here, we have all values to apply the quadratic formula. Our a is equal to 5, b is equal to 6, and c is equal to 10. So we're going to end up with x is equal to -b plus or minus the square root of b squared minus 4ac divided by 2a. Or x is equal to -b would be -6 plus or minus the square root of 6 squared minus 4 times 5 times 10 divided by 2 times 5. And this is going to give us the complex roots technically within the next two steps, because we have x is equal to -6 plus or minus the square root of 36 minus the values of 20 times 10 divided by 10, or x is equal to -6 plus or minus the square root of 36 minus the values of 200. Let me fix the square root. And all of this is divided by 10. And at this point, we're going to be looking at x is equal to -6 plus or minus the square root. And we're looking at 164. Let me check it. So we're looking at 36 minus 200, 164. And it's actually -164 over the square root over the values of 10. At this point, we're technically done, because when we extract the I, it's going to give us an I value, which indicates it's a no solution. So let me just simplify it in that form. So we're going to end up with x is equal to -6 plus or minus I square root of 164 divided by the values of 10. And let me just simplify it, but this is going to be a no solution. The moment that the I show up, that's an indication that there's no x-intercepts. So let me simplify this 164. So 164, we can divide it by 4. So you're going to end up with 4 and 41, I think. So 4 times 41 is equal to 164. So that means that our solution, we can write it as -6 plus or minus I square root of 4 times 41 and all over the values of 10. So we're looking at x is equal to -6 plus or minus 2i square root of 41 divided by 10. We can technically take this further, but that's only if they wanted the complex solutions. In this case, since they want us to solve and they don't mention anything about complex solutions, that means that this is a no solution. So you would simply say, at this point, stop here and automatically say no solution. There are no x-intercepts. There will be problems later on where they do want us to find all solutions, including complex numbers, and they would include that in the solution. And we would have said, well, in that case, this would be technically our answer. We could still simplify it further if we separate it. But at the moment, since we're solving within real numbers, we would just stop there and automatically say the no solution. That's because of the value of the I. Okay, that's actually it for this problem.